Hello everyone, I'm Andrew McGill. I'm a programmer working on Fruit Ninja 2 at Halfbrick Studios. In this session, I'll be covering the tools and components we created to give our artists and designers more creative control when working on Fruit Ninja 2. So let's get started. When Fruit Ninja 2 was first being developed, we wanted to implement a system that would allow designers and artists to be able to create state-driven content. Giving this control over to artists and designers would reduce the time that they had to spend making requests of code to update the state of objects or create new values for components that they were working on. This would allow them to freely iterate and create dynamic content that could react to changes in the game state in real time. So the core ideas or core principles behind these components we're going to create would be that they are simple and intuitive to use. They can be used to affect or adjust the properties of as much of an object as possible. And it should be simple and easy to scale the system if required. So what should these components look like? They should obviously be intuitive components. It should be obvious when you look at these components that what each property does and how those properties can be used to affect the other components on the object that you're working with. They should be reusable across any object as much as possible within the game, and they should allow artists and designers to iterate freely, as previously mentioned. Most importantly, though, these components should limit the need for code support while artists and designers are working on these objects, or at the very least, reduce how much code support is required. So how did we approach creating these components? What we decided to do was replicate a model view model architectural pattern, which the basic outline of is that you have a model, changes in the model update the properties of your view model, which in turn notify your view about what it should be displaying or how it should look. In the terms of Fruit Ninja 2, the model is the player's saved data. When that state changes, there's a lot of callbacks to what we refer to as data sources, so view models, which hold a lot of properties about the state of that data, which can then be used to assign values to different components within our UI or just objects in the game in general, which will then update the state of the UI or what those objects are doing and will display different information to our players. So what do these components actually look like in Unity? Well, let's have a look. So see here, we're in the landing scene of Fruit Ninja 2, and you can probably tell that there's already a whole bunch of components here on our UI that are populated with data. See all these season pass items, the different icons to access different parts of the UI, and our players' currency balances up here. So as an example, let's drill into the season pass object here. So we can see here we've got a little level badge. If we actually just access this text level component here, it will show you that it just looks like a regular object. But if we come down here to this component, the data binding component that I mentioned, we'll see that there's a couple of different properties on here we can use to affect the information displayed here on this object. Basically, if we look at the first couple of properties here, we'll see we have a target property, which if we click in here through reflection, we'll grab all of the other components that exist on this object, and we can then, in turn, target different properties on those objects and update their values or their current state, which let's stick with the text component for now. If we come down one level lower, we'll see we have a source value, which will access properties within our data sources that I mentioned before. So based on the type of target we've chosen, the information from data sources we can assign will be changed. So currently we can see that it's accessing the current level value of our player's season pass. So that is their current progress through the season pass, which we can see has a current source value of 7, which is then displayed in our game. So as an example, let's say for some reason we wanted to display the number of new blades a player has on their season pass level. swap that out, and we'll see here that it's instantly reflecting that I currently have no new blades. So you can see that updates in real time and populates with data straight from the player's save state. Let's change that back to our season pass value. Cool. So if we come up a little bit further in the hierarchy here, we'll see we have a in progress object to this season pass entry point. So we can see here again that it's targeting the set active property of our game object. It's grabbing a value, is track complete? So have they finished the season pass track? All of the rewards that are available have been collected. And that's currently false. And we can see here we have this opposite bool value property, which means that if this is false, then the bool value that it's targeting should be true, which we can see that yes, the season pass is still in progress. So if we disable that, see that the state changes on this button and it's reflected instantly. Still another high-level example, but one with a little bit more detail. So we can see here in our event select screen, we have a whole bunch of different entry points to events that are all populated through these data binding components and information saved in configs or the player's data. So we can see here that the art is updated through these configs. We have some properties about these events. That this one requires an info button to give the player some information about how that event works. If the event costs tickets, names of the event, how much time is remaining in that event. And if we actually select some of these components in our scene view, we'll see that tickets, we've got that. We've got a little object here that says uses tickets, which again targets the set active property of the game object, and this mode doesn't indeed use tickets, so it will show this little icon. So if we look at some state changes here, we'll see that currently we have this event at the end here that's in progress, in progress of unlocking. So if we come into our debug menu here, select our arcade score challenges, and we just force unlock that event, we'll see that instantly its state is updated and it reflects the changes in the player's data. You can also see here, because this is a new event, artists have set up a little new ribbon which uses the has seen info screen data source value to tell this object that it should be displayed, because we haven't been into this info screen yet about this event. So if we do actually enter this event and then come back out, see that tag is gone and it's no longer a new event. So again, this is a pretty high level overview of how these components work. So why don't we jump into a demo scene that I've set up and look at how we would go about creating one of these objects from the ground up. So if I jump into this scene and just wait a little bit for it to load, we'll see here that we have a bunch of event cards that all are identical because none of their components have data binding values assigned to them. You can also see here that there's a couple of buttons that will update the state of these cards, but again, nothing happens because we're yet to actually hook that data up through these components. So let's just quickly have a look at what these components should look like when we're finished with them. Just swap out the prefab that it's instantiating. And we'll see that we now have a bunch of locked events, but they have their different times remaining. They have their different names, different feature art. If we come in here and we say, give it a valid index and then say we want that event to be unlocked, look at that. It unlocks and it plays a little animation when it did unlock. Cool. So before we go about taking our empty prefab here and hooking it all up, let's just have a quick high-level look at what this data source looks like in code. So this is it. So as I mentioned, they're quite simple. The actual data sources themselves. There is basically this data source as a class, which then has a class within it, which is an iData source. And we can see here that it's just filled with pretty simple values that working in Unity you're probably quite familiar with, which are then stored in an array, which is here updated when our little demo item manager awakes in the scene. So if we look here within this update demo data source function, we'll see that it grabs the array out of our instanced data source here, and it will check basically if that data source array exists, or if the length of the objects that it's getting information from, which are some scriptable objects I'll show you in a moment, has changed. It'll recreate that data source array, and then once it's been created, it will iterate through that array and basically just populate it with information from the configs that I will show you. And that's really it. That is how all this information is put into a data source and then displayed. Obviously, if we were actually interacting with player data, it would be a little bit more complicated, and we would have some way of communicating when that player data has been changed or saved, calling back into this update of the data source and reflecting those changes. So if we just quickly have a look, I'll show you. As I mentioned, we have a couple of scriptable objects here that just have information about the couple of event cards that sort of popped up here before, what information should be displayed on those and what they should look like. So as I mentioned, we had a little manager here in our scene. If I just jump back to our scene. Yeah, so there is a list of these configs here, which creates the 4 entries in our data source and the information that's within those. So let's start hooking some of this up and getting to what it should look like. So let's start with the most obvious things. Let's start with the art. So we saw in our configs that we had some backing art, we had some feature art, and we had a border color and an icon, sorry. So let's come in here. Let's start with the backing art. Let's add our data binding component. Let's target the sprite of our image component, and we drop the backing art value on there. And that is that. Now, when the game runs, the backing art should be updated to match this the avatar backing that I already have assigned here, but just for the sake of seeing it actually happen, let's remove that for now. So we also had these border components, which you might have noticed in our setup prefabs, were different colors for each card. So if we open up our image component, and this time instead of a sprite, we target the color of this component, we can come in here and we can use our border color value to update that color. And we had another border here under our feature art, so we can just copy that component and drop it straight on there. And it should all be assigned correctly. It is. It's also similar again. We can actually probably just come in here and copy this component. Drop that on there and then change its source value to feature art. And we had one last art item to update, which is the event icon. Again, paste our component in there, and we'll swap that to the icon. Cool. So let's just swap that prefab back to our empty version, which is no longer so empty, and we'll run the scene and see what has changed. So look at that. We now have the feature art is updated. We have different colored borders on each of our cards. Our icons have updated. And yeah, we are on our way to having the component matching the setup version. So let's jump back into here and we will move on to some bool value properties. So it wasn't apparent, but there is this active property, which is this card representing an event that's currently active in our little demo scene here. So let's drop that data binding property on there. We'll target the set active property of this component, and we will use our isActive property from our data source. We also have another bool value that we need, which is this event unlocked? So in our mask object here, we have a locked overlay component. Should also have the set active property targeted with the source value of isUnlocked. And there we go. Now, when we run the game, we should see all of our events by default, I believe, should be locked and active. And then we can use our handy buttons here to... Oh, I have made a mistake here, actually. So our value here is unlocked, so it should be the opposite bool value. So if it is unlocked, all of that will display as we expect. Cool. So now we can see here that in our scene, because I've swapped that to the opposite bool value, our unlocked value is false because the event is currently locked, which means that this overlay is active. So now, similar to our event cards as before, if we come in here and target index 0 and hit unlock, the state updates as we would expect it to. Okay, so we're almost at parity with our setup version of this prefab, but we still have just generic X values for progress and a timer that never changes. We also don't have event names, so let's set those up. Cool. So we've got our timer here. We don't need to data bind the timer title because that's unchanging, but we do need to change the timer. So again, we just add the data binding component. We target the text of our text mesh pro object, or component, sorry. And we target it with the time remaining value. Then we have an event name, which again, let's just copy our component and drop it on here. But we will take the name property instead of time remaining. So that's 2 of the 3 done. Our progress ratio is a little bit different. But again, we simply, for the current progress, all we need to do here is add a data binding component targeting the text, add our current progress value there. And again, same thing for a max value. But as you'll notice, our max value displays a divider and our max progress value. So what we can do here is actually format the text with our little string format, which means we can then select max progress, and our object should be basically up to parity with our setup version of this prefab. Cool, look at that. We have varied timers. If we unlock, let's unlock index 3 this time, we'll see we've got a progress value that actually looks somewhat like progress value, and we'll see that all of our events have names. So there was one more thing that our setup prefab was doing that our empty prefab is not, which is there was a little animation that played when this object unlocked. So let's jump back into our prefab and make that happen. Cool. So we actually have here a Animator component that was already attached, but obviously wasn't updating. If you guys are familiar with the Animator, you'll know that they have states themselves, and they'll have parameters, which can be bool parameters, which can be set and then told the transitions, tell the animator using these bool parameters to transition between states. So what we've done here, and was a part of the easily scalable and modifiable nature of the system, is that we've created some helper components like this animator bool param component, which will basically grab an animator off the object it's on, and you can target the Boolean parameters on that animator through this component. So we can simply add a data binding here that will target our animator bool param component and the bool value on that component, and we can tell it that when the event is unlocked, it should set that Boolean parameter true, which will transition through to our event state. So let's see if that works. Cool. So we can see here that our events are still locked. Let's take index 1 in this case, and let's unlock it. Look at that. Our little image pulsed, as we expected it to with our animation when you unlock. Let's just do that again with index 2, just to be sure. Working perfectly. Okay, so you can see through the few examples there that data binding component can target and modify values of other components, and that we've used editor tooling to simplify the user interaction with this component by using reflection to give people simple menus for picking target properties and grabbing source values out of data sources that exist in the game. So the system as well is quite simply expandable. The preview of a data source I showed you with the basic values in it and how those are populated, you could see how you could easily add new Boolean parameters or new int values to that data source and take the values from your configs that you create or from your player's data and simply populate those data source values when that data changes. And through the helper components like the animator bool param, we can take other components that would normally require more complicated state setup and target parameters within them using the data binding components to drive changes in animations or other such components in the UI. Cool. So thank you for attending this Unite Now session on creative freedom through data-driven components in FreeNinja 2. I hope that you found some of the information in this talk helpful and learned a lot that might be able to help you build your Unity skills and advance your projects. And feel free to provide us with feedback. Finally, be sure to check out our Unite Now page for other sessions that are sure to inform and inspire you.